Hello everyone, welcome back to my channel InfoSec Lab, and today is going to be another video from attacking and defending AWS services from TryHackMe learning path. In today's room, the learning objectives is to learn about the basics technology associated with AWS platform. These technologies represent foundations concept for how you interact with AWS and AWS services. Once completed, you will have learned about the basic security boundary, an AWS account, and the root user account associated with each AWS account, the identity and access management infrastructure inherent to using AWS, what is an AWS region, and why that matters when you interact with AWS services, how AWS organizations can streamline operations through central management of multiple or many AWS accounts, and what is a virtual private cloud, and why you will almost inevitably need one or many when using AWS. This information will help you become familiar with core AWS services and features. Using this information, you will be better prepared to understand troubleshoot new challenges as they arise in your cloud journey. Alright, so let's get started. Basic concepts: AWS account and root user. AWS account. An AWS account is a container for your AWS resources. AWS accounts are designated by a 12-digit number, known as account ID. Each AWS account ID is unique and can never be reused. AWS also notes that an account is also a security boundary in association with AWS Identity and Access Management. Learning AWS IAM is an entire module by itself, but it is key to understand that AWS IAM or root user credentials are the only way to access the AWS control plane. Even when using single sign-on and third-party identity providers such as Azure AD or Okta, the permissions are granted on AWS IAM roles user or role. AWS account root user. To sign up for an AWS account, AWS users provide a root user email address. An email address can only be used as the root user email address for one AWS account. The root user is considered an IAM super user and has complete administrative permissions against the AWS account. Generally, AWS customers are recommended not to use the AWS account root user credentials unless performing a task that only root user can perform. By default, root users do not have multi-factor authentications enforced. Furthermore, root accounts that do not have MFA enabled or a phone number set are susceptible to weak password reset workflow attack. This is commonly the case of AWS accounts created automatically using AWS Organizations service, which we will discuss in another room. If an attacker gains control of the email inbox of an AWS root user without MFA or a phone number on the account, the attacker will be able to send password reset email and complete a takeover of the targeted AWS account. If you have access to an email inbox or are looking to target an email address as potential root users, you can use tools like QuietRare to enumerate valid root user email addresses. So how many digits are there in AWS account ID? 12. Does AWS require customer to enforce MFA by default for root users and credentials? Well, it's not enforced by default, but yeah, so 9. Basic concept number 2, identity and access management. AWS Identity and Access Management specifically means that the capabilities and features of the IAM engine and service of AWS. This is the underlying system built by AWS to determine how IAM principals are granted access to specific services, resources, and capabilities in AWS. Essentially, IAM principals are the identities that AWS recognizes as having privileges in relation to AWS resources in the AWS IAM engine. You can use the following policy evaluation logic from the AWS to determine whether or what type of access an AWS IAM principal has to a specific AWS service and resource. The policy evaluation logic image start with an implicit deny. IAM roles. AWS IAM roles are AWS principals that have permissions in relation to AWS services and resources. AWS IAM roles are notable because of a feature known as assume role or switch role. These terms mean that other identities recognized by AWS IAM are allowed to gain the privilege of a particular IAM role. Which identities are allowed to assume or switch to a role is determined by what is known as the assume role trust policy that is attached to each IAM role. Below is an example of assume trust policy. So this is the version, the statement, and then within the statement you have the effect, which would be allow or deny. So basically it would be deny the permission or grant the permission, and the principle is going to be the maintenance role. Action is to assume the role. So in the above example, the role maintenance role in AWS account 11111 would be able to assume a specified role. However, numerous types of an AWS IAM principle can be specified in an assume role policy, including federated identities. So, federated identities and identity providers. AWS IAM supports the use of Securities Search and Markup Language 2.0 or SAML and OpenID Connect or IDC to federate identities from third-party identity providers such as Azure Active Directory AAD, Ping Identity, Okta, Facebook, and any other SAML 2.0 or OIDC provider. This means that identities registered with these third-party providers can be provisioned access to AWS IAM roles with specific privileges inside of an AWS account. In 2017, AWS furthered this integration with AWS Organizations and IAM Identity Center, success to AWS Single Sign-On. IAM Identity Center. AWS Identity Center allows organizations to provision access across AWS accounts and application hosted as a part of the AWS organization. Inside an AWS organization, AWS Identity Center will allow customers to provision third-party IDP access to specific permission sets in a single AWS account, an organizational unit, or an organization root. Furthermore, using capabilities such as System for Cross-Domain Identity Management (SCIM 2.0), AWS customers can automatically update which permission set a user has based on user attributes or group membership in the originating IDP. This means that organizations can seamlessly manage access to AWS from the source IDP without the manual overhead associated with IAM provisioning. What logic can be used to determine the access of AWS principal? So what's logic? What logic can be determined to the access of an no. What logic? Is it policy evaluation? Okay. What policy determines if an IAM principal has the ability to gain the privilege of a particular IAM role? Is trust policy or assume role? Assume role. Okay, moving on to the next concept, AWS region. Global and regional service. AWS services are considered either global or regional. A global service means that the service supports a central control plane and data plane management APIs that does not resolve to a specific AWS region, whereas with a regional service, the control plane and associated data plane resolve to a specific region where AWS data centers are housed geographically. For instance, US East 1 resolves to Northern Virginia data centers in the United States. This is a valuable concept for organizations with data sovereignty requirements, but it also serves as a redundancy capability for organizations that architect multi-region workloads. You can find a list of regional AWS services here in this link. It takes you to this URL right here. Okay, notable global services. There are a few notable services that you should be aware of that are global services. CloudFront, content delivery network. CloudFront allows AWS customers to expose resources to the public internet. Route 53, domain register and DNS provider. Route 53 also allows AWS customers to expose resources to the internet. Organizations, AWS Organizations Excel is a global service. IAM, the access and authorization service for AWS. IAM determines what services and resources customer identities can access. AWS also has a service known as the Security Token Service, STS. STS is a key service to understanding AWS security, and it allows AWS and third-party identities to retrieve temporary access credentials. Uniquely, STS is both global and regional service. This means that STS has both global API endpoints and regional API endpoints. Though it is counterintuitive, STS tokens banded from a regional endpoint are valid in all AWS regions, whereas tokens banded from the global endpoints are only valid in regions enabled by default. In a similar case, the namespace for S3 buckets is global. This means that once a bucket name is registered, there can be no other bucket across AWS with the same name. However, S3 buckets are stored regionally in multiple availability zones, depending on the storage class and selected for the buckets. Default regions. Until 2017, all AWS customers had a default region US East 1. This means for long-standing AWS customers that AWS assumes the customer identities are using US East 1 unless another region is explicitly declared. Over time, this caused a disproportionate amount of AWS customer resources to be deployed to US East 1. Since 2017, US East 2, Ohio, or US West 2, Oregon, are the default regions for new accounts. Beyond having a default region for provisioning resources, certain AWS regions are disabled for customer user by default. These regions are Africa, Asia Pacific Hong Kong, Asia Pacific Hyderabad, Asia Pacific Jakarta, Asia Pacific Melbourne, and the list goes on and on. These regions are not accessible using STS Global API Endpoints credentials. As an AWS customer, if you want to use one of those regions to deploy resources, you will need to manually enable this associated region and use the regional STS API endpoint to retrieve credentials. Right. Let's move on to the questions. What AWS has both global and regional API endpoint STS? Security Token Service right here, STS. If your AWS account was created prior to 2017, what's the default region is US East 1. Alright, moving on. The next concept, AWS Organizations. 2017 beginnings of AWS Organizations. AWS has been around for a decade with only one concept of an account to centralize management of a company's AWS resources. For large organizations, managing everything in one account was challenging and inflexible. Furthermore, managing each team or department in separate accounts didn't scale well. So in 2017, AWS decided to introduce the AWS Organizations service. AWS Organizations allow AWS customers to centralize and standardize key AWS security and operational management capabilities. A key value of AWS Organizations is the concept of workload segmentation. By collecting accounts under an AWS organization, AWS customers can track various AWS accounts while segmenting individual workloads, like applications, networking, infrastructures, etc., into individual accounts, each with a separate security boundary. Gone are the days of putting all resources in one account. Organizational routes, organization units, and accounts. Inside an AWS account, excuse me, all AWS accounts are collected in a parent container known as the organizational root. The hierarchy in the below image can be summarized as follows. An organizational unit, OU, is a subcontainer under organizational root that may include multiple AWS accounts. Excuse me, so these are the OU. These are the OUs. An OU can contain all the nested OUs, see infrastructure OU and security OU. So right here. So these are OUs, and within these OUs we have sub OUs, infrastructure, security. Okay. An OU can contain one or more AWS accounts. See network, share service, security, log archive, and 10x AWS accounts. So these are going to be the AWS accounts within the OU. An AWS account can contain one or more user account. Okay. So this is an AWS account, and then user 1, 2, 3, and so on. Okay. Organization management account. AWS organization management accounts are the primary account associated with any specific AWS organization. Inside each organization management account are a set of roles that can be used to access any account in the organization. By default, this role is named Organization Account Access Role and has full administrative permissions against the associated child account. Using the management console to switch role or the AWS CLI to assume role, any IAM principal with privileges to assume these roles may be able to perform administrative activities across the organization. The organization management account is intended to host organization while logging using CloudTrail Organizations Trail, which allows AWS administrators to monitor control plane activities in AWS. AWS organization accounts can also host single sign-on SSO configuration or SSO configurations to manage identity provider, Active Directory, Azure Active Directory, Okta, Ping Identity, etc. integrations. Enterprises and other organizations use the AWS IAM Identity Extender to access child account roles and AWS hosted applications across an AWS organization using the integrated IDP credentials and authentication processes. Organization policy. AWS organization policies such as service control policies allow AWS customers to place restrictions on each child account in an AWS organization. SCP or service control policies specifically allows AWS customer to place highly customized security and access restrictions on the organization root or use all individual accounts. By default, AWS organizations are attached an SCP named P fully access to each account, which allows subscription to all AWS services. Each root, OU, and child account can have up to 5 SCP attached, and these policies allow restrictions such as allow only approved services, deny root user access, require use of IMTS version 2. Excuse me. Region restriction enforcement, deny ability to leave organization, deny ability to make a VPC accessible from the internet that isn't already. Notably, organization policies do not apply to the organization management account. This means that for IAM users enrolled in the organization's management account, SCP or service control policy restrictions are not effective. And here are some other AWS Organizations capability. AWS Organizations has a number of other capabilities that allow for centralized service management for organizations' managed account. You can use the following services with AWS Organizations to manage configurations of child accounts. AWS Account Management, manage contact information related to accounts. AWS Artifact, accept legal, contractual agreements on behalf of accounts. AWS Audit Manager, automated evidence collection from audit activities. AWS Backup, centralized management and monitoring of backups and backup plans for accounts. AWS CloudTrail, centralized login of AWS control plan activity. Amazon CloudWatch events, share monitoring event data across accounts. AWS Compute Optimizer, identify opportunities to improve compute efficiency based on AWS recommendations across accounts. AWS Config, aggregate and analyze assets, resource configuration data across accounts. Enforce configuration requirements across accounts. AWS Control Tower, automate governance and provisioning of accounts in association with AWS Organizations. AWS Directory Services, provision or integrate Active Directory domains with account. AWS Firewall Manager, centrally manage configurations of AWS Web Application Firewall or WAF rules across the accounts. AWS Guard Duty, automates detection and response to security incidents across account. AWS Health, centralized visibility into potential health events related to AWS resource performance and availability. AWS IAM Access Analyzer, analyze resource-based policies to determine what external accounts or principals may be trusted across the accounts. AWS IAM Identity Center, allows customers to configure a third-party identity provider or use AWS IAM Identity Center to provision access centrally. AWS License Manager, centralized management of third-party software licensing. AWS MASI, data identifications and classification across accounts. AWS Resource Access Manager, share data resources across accounts. AWS Security Hub, check organizations manage accounts for security compliance and configurations related to governance standards. AWS Service Catalog, share and manage IT service capabilities, AWS resources across accounts. AWS System Manager, manage and monitor virtual machines across accounts. AWS Trust Advisor, AWS automated best practices analysis across accounts. Last but not least, AWS VPC IP Address Manager, or IPAM, plan, track, and monitor IP addresses accessing VPC-bound resources. As there are a lot of services. As there are so many different capabilities, we will not go into detail regarding the specifics of each service. However, it is important to understand, as both a defender and attacker, the native security tools AWS offers and how they impact the attack lifecycle when implemented. What AWS Organizations made generally available? 2017? Yes. What the subcontainer for accounts in AWS Organization, Organizational Unit, OU. What AWS Organizations account does the service control not apply to? It was AWS Identity Management. Okay, with AWS policies such as service control policies allow AWS customer to play restrictions on child account. Allow AWS customer to place highly okay by default a child, which allow AWS each. This means that for IAM users and roles in the organization management account, SCP restrictions are affected. Okay, so it's going to be the organization management organization management. All right, the last basic concept, VPC components. At the core, a virtual private cloud, or VPC, is a software-defined network topology that represents AWS traditional network infrastructure offering for customers. VPCs allow AWS users to restrict the connectivity to sensitive resources designed to be isolated or segmented from other workloads, and critically, from the public internet. The following network components are commonly found in AWS customer VPCs. Internet gateway allow communication between the VPC and the internet. Egress-only internet gateway allows an IPv6 address to initiate outbound connections to the internet but restricts inbound. Carrier gateway to establish direct communication with telecommunications carrier networks. NAT gateway, network address translation service. Gateway allow private subnets to connect to services outside of the VPC. DHCP by default, all EC2 instances in a non-default VPC receive unresolvable hostname assigned by AWS. This can be updated to leverage custom domains. DNS by default. AWS provides DNS resolution to VPCs via the Route 53 resolver, a global AWS DNS services. A global AWS DNS service. Public and elastic IP addressing. AWS maintains over 100 million public IP IPv4 addresses. Many of these addresses can be assigned by customer to specific resources. When using a public IP address, AWS term, if the associated EC2 instance is stopped, the IP address will be relocated to AWS, and a new IP address will be assigned if the public EC2 instance is ever restarted. However, with an elastic IP address, the IP is allocated for AWS account ongoing and can be assigned to arbitrary resources as the customer chooses. So this is a VPC. Within the VPC, we have two availability zones, Zone A and Zone B. And this is the router. Within this availability zones, we have 3 EC2 instances with 3 different IP addresses. And then this is also are the 3 EC2 instances. And this is the virtual private gateway VPN connection that connects to the outside external network. Alright, and these are the custom route table. Default VPC service capabilities. Beyond the common components found in AWS VPC, certain service capabilities are configured by default in any AWS VPC using linked local addresses, which are only valid in the local network segment. Why these service capabilities are enabled by default? AWS user can configure and disable the following services. DNS resolvers found at 169.254.169.253 in each VPC. This is the Route 53 resolver discussed above. AWS customers can disable this service and implement their own DNS server. Amazon Time Sync service using Network Time Protocol (NTP) found at 169.254.169.123 in each VPC. This service performs time synchronization for computer instances. Microsoft KMS service found at 169.254.169.250 and 251. This service allows AWS customers running Windows to activate Windows licenses via Microsoft KMS without having to connect to the internet. EC2 Instant Metadata Service found at 254.169.254 in each VPC and abbreviated as IMTS. This capability allows EC2 instances to retrieve information about the instance performing the query, including data for startup scripts, network interfaces, and potentially instance metadata credentials that were famously used for privilege escalation in the 2019 Capital One breach. EC2 Task Metadata Service found at 169.254.170.2. If a customer is using Elastic Container Service (ECS) to provision infrastructure, this metadata endpoint is used similarly to the EC2 Instant Metadata Endpoint. VPC endpoints allow AWS customers to integrate specific AWS services with their VPC without requiring customers to use an internet gateway, NAT device VPN connection, or AWS Direct Connect connection. Interface VPC endpoints allow customers to integrate eligible AWS services using AWS Private Links, a service designed to allow such connectivity without exposing the connection to the internet. Gateway load balancer endpoints can be used for traffic interception and associated inspection. Okay, so this task is only explaining the basics of VPC. Please see the room dedicated to VPC for an in-depth look at these technologies. Okay. What AWS services host the AWS DNS resolve? Oh, that's Route 53. What VPC features were used for privilege escalation during the 2019 IMDS Instant Metadata Service? Instant Metadata Service. What type of VPC endpoint will allow for all network traffic inspection? VPC endpoints. No. Gateway load balancer. Okay. Yeah. Gateway load balancer. Sorry. Gateway load balancer endpoints can be used for traffic interception and associated inspection, which is right there. Summary view site. Start site. In this room, you have learned about the core AWS services and features. These capabilities are defining features of AWS as a user and attacker. You should understand the following concept: how AWS accounts and root users relate to AWS security at the basic level, what AWS IAM is, and some of the key features you will encounter with IAM. How most services are regional and the difference between a regional and a global service. The wide variety of AWS services that can be centrally deployed or managed using AWS Organizations. How software-defined networking allows AWS accounts to create and interact with the network-bound resources within the VPCs. You may never log in as root user if you don't have your own AWS account, but you will encounter this concept while working with AWS. Click the websites, okay. Why is the flag after completing this exercise? Okay, what is it? Use your knowledge of AWS concept to click on the correct interface elements to perform 3 tasks. Find the 12 digits of AWS account. It's right here. Okay. Switch region from North Virginia to Asia Pacific. No. Sydney, right? Yes. Hooray! Region switch from North Virginia to Asia Pacific, Sydney. Create a VPC with CIDR set 10.001.16. Create VPC. with a set. Yep. 00116 and then and tendencies set as dedicated. Ten to 00.1.16. Okay, this is VPC only. Okay. All right, got the flag. Yay, we complete another room of AWS. Congratulations. Okay, so I know this is a little bit dry. We only go over the concepts of AWS, but I promise you that for the next following rooms, it's going to be exciting and then sometimes confusing too. So hopefully after this room, you get to know more about AWS services and what they are, as the more basics you get to understand and get to know about AWS, the easier it is later on when you follow the following rooms, because they're all interconnected. Everything is connected together. So hopefully you have fun with this room. And thank you for watching. See you.